Right, this video starts with a wee bit of revision, firstly about trigonometric graphs. We've seen before the shapes of sine and cosine and tangent graphs. Now the important points on each of these graphs occur at 0 degrees, 90 degrees, 180, 270 and 360. These are the values which you should be able to work out relatively quickly from memory. So for a sine graph, the 5 values we've got are sine 0 is 0, sine 90 is 1 at the very top, sine 80 we come back to the middle, sine 270 is at the bottom, sine 360 is back to the start. Similarly with the cosine graph, here are 5 values. Remember, cos starts at the top, goes right down to the bottom halfway through for 180, and then back up to the top at 360. The height is equal to 1. The tan is slightly different. It only has a period of 180, so the values repeat after 180 degrees. But remember, for 90 and 270, it goes off the page. It's undefined, infinity. So these are the values we should be able to work out quite easily from just sketching our graphs and reminding ourselves of the patterns. What we now need to do is look at 3 different values: 30 degrees, 45 degrees and 60 degrees. Now the challenge is we need to know what these values are without using a calculator. It's not just a case of guessing, we can still work them out. But what we need to do is remember how to use Pythagoras and basic trigonometry, our SOHCAHTOA. So what we're going to do is look at 2 specific right-angled triangles and use them to get our values for 30 and 45 and 60. The first one is isosceles, and it's also right-angled. Now we've said the sides that are the same have length 1. If they're isosceles and right-angled, the angles at each other corner are 45 degrees. So what we can do is use Pythagoras. So we generate this root 2 value by doing 1 squared plus 1 squared and then square rooting. That gives us root 2 on our hypotenuse. Now using the basic trigonometry and our idea of SOHCAHTOA, if 45 degrees sits in this corner here, then the opposite side must be over here. We know the hypotenuse is opposite the right angle, the adjacent side is the one that's left. So again, using opposite and hypotenuse for sine 45 is 1 over root 2. Cos 45 is the adjacent side over the hypotenuse, which again is 1 over root 2. Tan 45 is opposite over adjacent, 1 over 1. We just simplify it down to 1. Now for the second 2 sets of values, for 30 and for 60, we use an equilateral or equilateral triangle. Now you'll notice I have put all the angles in, 60 degrees, and I've made each side equal to 2. Now because it's equilateral, all the sides are the same. You'll see why I've made it 2 in a few seconds. Because I'm going to do this. This is why it says bisected at the bottom, because I'm going to split it into 2 equal parts. I'm going to create a right angle at the bottom, and you will then see that the base of the triangle is now 1 unit. The top angle is 30 degrees, so I can use this triangle to generate my values for 30 degrees and for 60 degrees. Now we'll start with 30 degrees first. The missing side is going to be using Pythagoras 2 squared minus 1 squared because it's not the hypotenuse. so that works out as root 3. Using 30 degrees at the top, our opposite side is down here. Our hypotenuse is opposite the right angle, the adjacent side is the one that's left. So, sine 30 is opposite over hypotenuse, which is 1 over 2. Cos 30 is adjacent over hypotenuse, which is root 3 over 2. And tan 30 is opposite over adjacent, 1 over root 3. Now for the 60-degree angle, all we do for this triangle is we swap the opposite and the adjacent sides around, because if the angle is now here, the opposite side is now this one here, this root 3 side. So, using the same process, using trigonometry, we've got sine 60 is opposite over hypotenuse, root 3 over 2. Cos 60 is adjacent over hypotenuse, which is 1 over 2, or half. And tan 60 is going to be opposite over adjacent, root 3 over 1, or just simplified down to root 3. Now these values will be very, very useful. They can be easily calculated just by using, as we've said before, Pythagoras and SOHCAHTOA. And the principle of what we've just seen is going to be really useful when we deal with different angles that we don't know the exact value of, like 30 or 45 or 60.